then I have 3 parentheses here. Why? Because when I raise something to the 3rd power, that means we have 3 of them multiplied together. So this is x minus 2, x minus 2, x minus 2. Okay. Let's go through all of our things then. So I'm going to also just add this in. All right. Would you write down what you think the degree of this polynomial is? Take a look at your partner's paper, see if they get the same thing. All right, did you put a degree 4? Does anyone need me to talk about that? Okay, what's the leading coefficient? Again, write down on your paper, check with somebody around you. The leading coefficient should be a 1. All right, x-intercepts, would you write those down? Just a show of hands, how many different x-intercepts are there? Even though I see 4 of these things, there's only 2 because this one shows up 3 times. So the 2 you should have written, remember they're opposites. So -1, 0 and 2, 0. Yes, ma'am.
You didn't stop the negatives and positives. You moved up for that. Are you supposed to switch them to 5 and 2s?
No, so I think what you're thinking of is this. If it's written as a factor, we're going to write it exactly what it looks like, okay? But when I list the x-intercept, do you see how I listed it as 2?
Yeah.
That's when you flip it, okay? Okay, with my degree 3 one, we're just going to go real closely. These are both going to go through. There's no double roots here because the time that it bounces is only when it says something with a squared. We're going to make it go through at 2, but when we do that, it's going to be like a flattening of the curve there. All right, if this is degree 4, leading coefficient 1, can you give me just a show with both of your hands where the end behavior goes? Degree 4, even degree, leading coefficient 1. So some things that I'm looking for are like this or this or this, or do you know what the end behavior is? Okay, I'm seeing some of you that are saying both up, and that's correct. Okay, so we know that the end behavior I'll say to the left is up and the right is also up. Okay, y-intercept. Let's see if you remember what I just taught you. Can you find the y-intercept of that polynomial? Did you write a -8 down? So 1 times -2 times -2 times -2 would give me my constant term, 0, -8. All right, on our graph, what I need us to do is at least, let's do a couple points to the left Well, a couple is 2. We'll do several points to the left and several points to the right. And then for my y-intercept of -8, if you want to do 8 tick marks, you can. Or if you want to just make a mark down there and make sure it's labeled -8. All right, so let's put an x-intercept. We're going to put a point at -1, 0 and a point at 2, 0. And which one are we going to make flatten? The 2. Okay, so remember my end behavior goes like this on either side. So I'm going to make this come down. I don't know what it does before -8. Maybe it just goes straight down and comes back up. When it comes through the 3, or the 2, would you make it flatten a little like that? And then continue up. Okay, we're going to do some practicing in a second of that. So, we're going to sketch a graph of this one. Wow, got a lot going on here, huh? Would you write down the degree of that polynomial, please? Did you write down a 6? Okay. Eaton coefficient is positive. Point for me what the end behavior looks like on this one. Give me some indicator. Like this, right? There's your left and your right. Okay. I'm going to just put some words to keep track because there's a lot going on here. I'm going to assume if I don't write anything down, it's just a regular old goes through the x-axis. So this one at -5, it just goes through. At 1, there's 3 of them. So is it going to bounce or flatten? Multiplicity of 3, that's what that means. Multiple factors. Is it going to bounce or flatten? Flatten, good. So at 1, 0, I'm going to just put, we're going to make it flatten out there. And then at 2, 0, we're going to make it bounce. Okay, then my question to you is this. What do you think the y-intercept is? Can you do some work on that a little bit for me? Let's see here. 5 times -1 is -5. Positive 5. -5. -5 times -2. Is what? And then times -2 would be -20, I'm thinking. -20? Okay. All right, let's do some work. For -20, I'm gonna make this be -10 and this be -20, just because I can really do what I want on a sketch as long as I label my points. I can make the scale work for me. So let's then go 5 to the right, and then 5 to the left, and let's put our dots on, okay? So we need one at -5, we need one at 1, 0, we need one at 2, 0, and then we need a y-intercept at -20. Okay. Are you ready? These are kind of close together, so we're just gonna have to go really small on that one. So what happens is on the -5, I don't know what it does. I'm gonna make it go down below, and then it's got to come up through the -20. Maybe it goes straight there. I don't know, but that's what I'm gonna do. And then the next one that happens is this 1, 0. What am I gonna do there? Flatten, but it's going to go through, okay? So we're going to do like a little flatter right here, but it goes through, and then we're going to turn around really quickly. At the 2, 0, it's going to come down and bounce off, so something like that. Okay, so what I want us to do then last is, what if I give you an equation for the graph? Can you go backwards? I bet you can. Okay. So, first of all, we want to double check at the end that this is an even polynomial with a negative leading coefficient. How in the world did I know that? What told me that? The graphs are, see how at the ends they're both going the same direction, they're going down. Okay, now let's just go through very slowly. Let's circle the -1. First of all, how would I make that a factor? If -1 is the x-intercept, how would I write it with an x? Brian, what do you think? Awesome. X plus 1. It flattens. Add something to it. Anything that's an odd exponent is fine. Let's make it 3. Okay. Next, we have 1. Kimberly, how would I write that as a factor? Good. X minus 1. This bounces. What do I need to add? Sure, a 2. Sometimes we'll talk about how you could do like 4, whatever. They can get crazy, but for us, let's just use 3 and 2. Okay, next one. X minus 2. Is there anything special on that one? No, we're going to just leave it as a regular, we call that a linear factor, degree 1. Okay. All right, now, if we were to write this out, there would be 3 of these, and then 2 of these, and then 1 of this. That gives me my degree 6. I have to do one little thing. Do you see it's both going down? So you need to add a negative number to the front. You can really add any negative number you want. I'm going to just make it -1. Okay, so then let's just at least, I think we're good with the graphing. Let's at least do it in a table form. The word multiplicity has multiple in it. What does multiple mean to you? More than 1, okay. So the multiplicity just tells you what we're going to put for our exponent, because that's just telling you how many factors there are there, okay. So if the x-intercept is -7, let's write our equation. I would write that as x plus 7. Agreed? And there has to be 2 factors there, so I write that as squared. How would I write an x-intercept of 1? X minus 1. It has a multiplicity of 3. That means there's 3 of them, so I would make that degree 3. I would write x minus 5. There's only one of those. Do I have to write the 1 in? We haven't been. No, you don't have to write it in. X minus 7. And there you have it. Okay. So,